Navigate the graphics and text results. Let's continue using the sample problem duct cover. Double-click FB to launch the frame builder. Click the Open button and open Samples, Frame, 2df_0aj, duct cover, select File ductcover.frame, open it. This sample's geometry and loading are already defined. Let's take a look at its geometry. Click Number 2 Geometry. This dialog box warns us not to change the geometry. We should not change the geometry because the loading is already defined. If geometry is altered, all the loadings need to be revisited to make sure they are still intact. So, click the blue Acknowledge to indicate that we understand that. This is the geometry. Let's change the resolution to 600 pixels. Although you don't want to change anything, you may want to use the top right action button to save a certain graphic to be used in your summary report later. Now, go to Top, click at the red X, close it. Back to the main menu, let's take a look at the loading. Click Number 3 Loading, a similar warning appears. Again, click OK. This is the Loading Manager dialog box. To the left, it appears that we have 4 primary load cases and 3 load combinations. 7 load cases in this analysis. Now, go to the top, click the red X button, close it. After model geometry is completed, loadings applied, the next step is to prepare the final report. Click Number 4 Report button and start this process. Before going forward, Frame Builder asks 2 questions. The first question is, what are the load cases to be considered for the final report? You may have many load cases, but only a few of them are to be compared to get the extreme and maximum values to validate your design. In our case, only the 3 load combinations are elected for final consideration. For green number 1, select all 3 load combinations, then, click the blue larger than button. For green number 2, click the next button, click OK to confirm. Here is the second question, what is the force and length units of the report? All the values of the report will be presented accordingly. The reason is simple, you may have used different units throughout the analysis, but the output units will be the ones selected here. For green number 1, select kip as the force unit, green number 2, select inch as the length unit. In the output file, all the forces are in kip, displacement in inch, stress in KSI, etc. For green number 3, click the blue Activate a new run button, click Yes, to confirm the unit selection. Now, the frame builder is analyzing your structure. Very quickly, it is done and the result has been generated in the background. This is the Final Report Manager dialog. Green number 1 is the Final Report Helper. It helps the user to navigate and validate the analysis. Then, collect data and graphics to be ready for the green number 2, prepare a summary report. After the result is validated, use the collected data to draw conclusions and insert supporting graphics to authorize a summary report. Once the summary report is done, the presentation-ready final report is also done. Simply click number 3 green button to view it. Let's take a look at the graphic output first. Look at the right side, under green number 1 Final Report Helper. Check the box of View or Save Deflection Shapes. It launches a dialog box containing a picture of duct cover. Now, change the resolution to 600 pixels. To the upper left corner, there is a drop-down menu labeled Load. Select Load Case LL. The deflection shape of load LL is drawn. Look to the right, the maximum values of load LL are displayed. From the top, maximum X displacement of 0.0359 inches at joint number 10. Looking back to the graphic, joint 10 is labeled. The maximum Y displacement is negative 0.038 inches at joint number 7, also labeled. The maximum axial member forces Fx is 1.44 kip, at member number 10, the maximum shear force is 0.67 kip, at member number 2, whereas, the maximum moment is 41.8 kip inch, at member number 10. Look to the graphic, member number 2 and number 10 are also labeled and drawn with double thickness in green color. Quickly going through the deflection graphics, you can see what is the response of the structure against loads and get an idea of the corresponding critical areas. If there is excessive deflection, it may indicate a weakness in design, or even a locally instability. Go to top, click at red X to close the graphic. How about the details of the analysis? Under green number 1, there is a checkbox of Text Report Viewer. Check the box of Text Report Viewer, it displays the output of the analysis. Scroll down, there are a lot of them. Duct cover has 9 joints and 7 load cases and 1,353 lines of output. For more complicated analysis, its report can easily go over 10,000 pages. To streamline the reviewing process, the report always starts with the extreme values followed by the maximum values of the selected load cases. Here, it starts with extreme reactions, displacements, member end forces, and member end stresses. Most of the time, the first 2 pages of report alone is enough for you to draw a conclusion. Let's go into details. Bring up the slide, reposition it. To the middle of the left panel, there is a doc map of the report. It shows the order of its presentation. First, extreme values of the selected loads. Second, maximum values of the selected loads. Third, details of the selected loads. Fourth, details of the non-selected loads. Fifth, details of the model geometry. Make your first selection from the doc map. And, your secondary selection from the contents. For this example, the extreme values is the first selection, and the displacement is the secondary selection. Then, the right panel displays the extreme displacement of the selected loads. Now we know how to navigate the output, we can validate the result of the analysis. Close the slide. Back to the final report manager. How to validate the results? The first question is, what is the total weight of the structure? Click to open the text report viewer under green number 1 final report helper. The weight of the structure is reported in the detailed model information. First select model from the doc map, next select seconds and mat from the contents. The right panel is now displaying section and material properties of the model. Here, we use 3 sections, the first one is W8 by 28, second one is W10 by 33, the last one is double angle 2.5 by 2.5 by 1/4 inch. Here, it reports the length, the weight, and properties of the section used in the analysis. The weight of W8x28 is 0.58 kip, for W10 by 33 is 1.5 kip, for double angle is 0.1 kip. The total weight is 2.18 kips. Now, let's validate the vertical load of load case DL. Following picture is the loading of the DL. Let's rearrange the location of the text report viewer. Check the vertical loads of DL. The dead weight of 1G is 2.18 kip, the member load on roof members is 0.008 times 240 equal to 1.92 kip. Total applied vertical load is 4.10 kips. Back to the text report viewer, select DL details and then, reaction. Look to the right panel, the total Y reaction of DL is 4.104 kip. Checked. Now, let's validate the horizontal load of load case EQX. Following picture is the loading of EQX. It has a 0.45 G horizontal gravity load, which is 2.18 kips times 0.45 G equals 0.98 kips. Also, it's 4 roof joints, each taking on 1.25 kips horizontal load. So, 4 times 1.25 equals 5.0 kips. The total horizontal load is 0.98 plus 5 equals 5.98 kips. Back to the text report viewer, select EQX details and then, reaction. Look to the right panel, the total X reaction of EQX is 5.9829 kip. Checked. Load combination is the summation of factored primary loads. As long as the primary loads are validated, we can apply factors to the reactions of the primary loads and sum them up to get the expected reactions. As a matter of fact, after a few projects on Frame Builder, you will feel very comfortable with it. During the validation process, you may collect data and save graphics for the green number 2 step, prepare a summary report. After the report is validated, use the collected data to draw conclusions and insert supporting graphics to authorize a summary report.